Hi guys, this is Srinivasa once again for you. I'm working as a assistant professor in Paida College PG courses. Today I'm going to discuss about Vigyam method or penalty method. So already the model also uploaded in YouTube, but the most of the students are asking about if the objective function is in the form of minimization or the constants are equality, inequality like this. So that is the reason why again I am going to upload this video, that is the Vigyam method, with a different LPP. Here we have some sort of a objective function in the form of minimization, that is 2x1 plus x2 in the form of minimization, and the subjective constant, the given data itself is our equality. So that is 3x1 plus x2 equal to 3, 4x1 plus 3x2 greater than or equal to 6, x1 plus 2x2 less than or equal to 3 with non-negative restrictions, x1 comma x2 greater than or equal to 0. So first of all we have to check whether the given objective function in the form of maximization or minimization. If it is a maximization, no problem. If it is a minimization, convert it to maximization by using minimax theorem. What is the reason behind this? Every company is looking for maximize the profit. So the object on war is with the minimum resources looking for maximize the profit. So here the objective is in the form of minimization. Now we are going to make it into maximization by using minimax theorem. That is the solution for this is as follows. So by using minimax theorem, so the statement of minimax theorem is maximum of just is equal to the minus of minimum of z. So which implies maximum of just equal to minus of. So what is the minimization function given? The given objective function, that is 2x1 plus x2. So that is in the form of minus 2x1 minus 2x2. This is all about maximum of just So with the help of minimax theorem, we made the given objective function in the form of maximization. Clear? Now after this, now we have to make all inequalities into equalities by introducing slack variable, surplus variable, that is the artificial variable like this. So the given the first term in the form of equality. For this case, we have to introduce an artificial variable, that is 3x1 plus x2. So the given function form of equality means we have to introduce an artificial variable a1 that equal to 3. The second constraint, that is 4x1 plus 3x2. This is in the form of gradual type, that is surplus variable. So that is minus s1. Already we introduced the slack variable, so that is the reason why we are introducing the next artificial variable, that is a2 that equal to 6. And one more we have, that is x1 plus 2x2. So this is the form of less than or equal to, we have to use the slack variable. So already we used the slack variable s1. Now we are going to use a slack variable s2 that equal to 3. Why? Because this is in the form of less than or equal to type. So now we made all inequalities into equalities by introducing slack variable, surplus variable, artificial variable like this. So after this we have a standard form of matrix. So the standard form of matrix is all of you. We have Ax equal to B, the standard form of matrix. So that is the standard form matrix is Ax equal to B. First of all, I am going to represent all the variables. X1 we have x2, S1 we have S2, and the rest of the artificial variable A1, A2. That is, so cost of x1 is 3 here. If you observe the quotient, that is 3x1, that is x1, the quotient is 1, S1 we don't have, again S2 we don't have, S1 we have, but we don't have A2. For the second one, 4, 3, S1 we have minus 1, S2 we don't have, 8, 1 also we don't have, that is A2, that is 1. The third one, 1, 2, 0, 1, 0, and again 0. With this is all about A, and what is X? X means all the variables x1, x2, s1, s2, a1, and again a2. This is all about. And what is B? B means the variable, that is 3, 6, 3. After this, the modified objective function. The modified objective function is maximum of just that is we made in the form of maximization, that is minus 2x1 minus x2, that is minus 2x1 minus x2. We introduced a slack variable, that is s1. The slack variable cost will be 0 plus 0 into s1 plus 0 into s2 we introduce the artificial variable a1, a2, the cost will be minus m, that is minus m into a1, minus m into a2. That is the reason why this method is called as big minus m method. So the cost of the artificial variable or the penalty is minus m. Then the first part is over. Then we will move on to the first iteration table. Now the first iteration table, that is the first iteration table. So that is we have all the variables. So there is CB, YB, XB. We have all the variables x1, x2. We introduced S1, S2, A1, A2. So in the first equation we introduce the artificial variable A1. So that is A1 we have to write. The cost of this artificial variable should be minus m. In the second equation we introduce a surplus variable, that is minus S1 plus A1. Then part A2, that is we introduce as artificial variable A2, the cost will be minus m. And in the third equation we introduce a slide variable S2. So S2, the cost should be 0. So simply after this we have B done. We have B. What is B? 3, 6, 3 as usual. 3, 6, 3. And I am going to represent this entire matrix here. That is 3, 1, 0, 0, 1, 0, 4, 3, minus 1, 0, 0, 1, and 1, 2, 0, 1, 0, 0. And we have a Cj, that is the model object function, minus 2, minus 1, 0, 0, the cost of which variable minus m, and here also minus m. After this, we have three major steps like in simplex method, that is the object function, that is maximum of z equal to summation cb into xb, that equal to minus 3m minus 6m, that is minus 9m. 0 and anything 0. After this we have zj. The formula for zj is summation cb into xj. Minus 3m minus 7m, that is minus 4m, obviously minus 7. And again minus m minus 3m, that is minus 4m. 0 minus into minus plus m. 0 again 0 and again 0 and again 0. And obviously minus m. And also we have minus m into 1 again minus m. After that we have a net diversion condition zj minus cj greater than equal to 0. Minus 7m minus into minus plus 2, that is we have minus 7m plus 2. And again judgment is minus 4m minus 1, that is minus 4m plus 1. So m minus 0 again m minus 0 minus 0 0 minus m minus into minus plus m 0, and obviously minus m minus into minus also plus, so that is 0. Minus and plus m gets cancelled 0. Here the net diversion condition is not satisfied. Why? Because here we have negative terms. So and hence we have a condition that is minus of maximum. So from these two the minus of maximum is, so minus 7 and minus 4, obviously the minus of maximum is minus 7. So after that we have a minimum ratio rule, that is a minimum ratio rule formula is of you xb by this arrow will indicate x1. So that is xb by x, 3 by 3, 1, 6 by 4, that is again 3 by 2, that is 1.5. Now after this again 3 by 1, again 3. So from this case, here we have minus of maximum, so the reciprocal of minus of maximum is plus of minimum. So what is the plus of minimum from these three, that is 1, 1.53, obviously 1 is plus of minimum. If you are going to combine these two, we will get a key element, that is 3 is the key element. So because of this key element only we are unable to satisfy this net diversion condition. So we got the key element. After we have to do two major steps. So the first step is we have to make this key element as unity by dividing itself and make all the elements in the key column has to be 0. The second iteration table as follows, that is the second iteration table. So as usual we have CB, YB, XB. as usual, x1, x2, s1, s2. Obviously, all of you, we have a key element that is 3. In the next step, x1 is incoming vector, a2 is outgoing vector. In Wickham method, a1 is not outgoing means we are going to remove this entire column. We are going to remove this a1 column, but not in case of simplex method. So I am going to reduce this column entirely, that is a1. So as usual, so because of that, we have x1, x2, s1, s2, a2. So we have Cj here, that is Cj that equal to -2, -1, 0, 0. The cost of A2 is obviously -7. So x1 is incoming, A1 is outgoing. So A1 is the outgoing vector. Here x1 is incoming here, that is obviously x1 should be here. The cost of x1 is here, the cost of x1 is -2. And there is no changes for the artificial variable a2 and s2. The cost should be -m and obviously 0. Now we have to make the key element to unity by dividing itself. So we have a key element is 3. We have to make this key element as unity by dividing itself. So without loss of generality, I am dividing this entire row by 3. 3 by 3 obviously 1. Again 3 by 3 obviously 1. Again 1 by 3. 0 by anything is 0, again 0 by anything is 0, and again 0 by anything is 0. After that, we have to make all the elements in the key column has to be 0. So now I am going to make this 4 as 0. So with the help of key row. So all of you again we have to take some sort of rough here. Now we are going to make this element as 0. Now my aim is to make this 4 as 0. That is, I am writing this 6, 4, 3, -1, 0, 1 with the help of a key row, that is 1, again 1, 1 by 3, 0, 0, 0. We have to get 0 here. So here we have 4. If we got 4 here, obviously we can settle. So without loss of generality, I am multiplying with 4 here. 4 ones are 4, again 4 ones are 4, again 4 by 3, 4 into 0, 0, 4 into 0, 0, again 4 into 0, 0. Now I am going to subtract these two. -6 minus 4, that is 2. 4 minus 4, 0. 3 minus 4 by 3, again 3 minus 4 by 3. 3 threes are 9 minus 4 by 3, obviously 5 by 3. -1 minus 0, obviously -1. 0 minus 0, again 0, 1 minus 0, obviously 1. Now I am going to represent this entire row in the second row, that is we got 2, 0, 5 by 3, -1, 0, 1 with the help of the key row. Now we have to make, so we made a key element as unity and we are going to reduce all elements in the key column has to be 0. We made 4 as 0. Now we have to make this 1 as 0. So you have to consider the entire row in your rough. That is, you have to consider this. So that is 3, 1, 2, 0, 1, 0 with the help of a key row. The key row is 1, again 1. We got 1 by 3, and the rest of the values are 0, 000. So likely we got 1, and obviously no question of multiplying with any number here. Simply I am going to subtract. 3 minus 1, that is 2. 1 minus 1, 0. Because of this only. 2 minus 1 by 3, obviously 3 2s are 6 minus 1, that is 5 by 3. 0 minus 0, 0. 1 minus 0, again 1, and again 0 minus 0. Now I am going to represent this entire row here, that is 2, again 0, 5 by 3, 0, 1, 0. So we made some sort of operations here to make all the key elements has to be 0. So now we made a key element as unity and made all the elements in the key column has to be 0, and we have our ideal conditions maximum of z equal to, the formula is all of you, summation cv into hv, that equal to -2 minus 2m, that is -2 minus 2m. We got 0, minus 2 into 1 minus 2, minus m into 2 minus 2m, that is -2 minus 2m and 0. Now that we have a formula zj equals summation cv into xj, -2, 0, that is -2 only, -2 by 3, that is -2 by 3, and minus 5m by 3. And after this 0, minus into minus plus m, 0, again 0 and again 0. We got again 0, again minus m and again 0, that is minus m only. After we have an intervention condition, that is Zj minus Cj greater than equal to 0. Minus 2, minus into minus plus 2, the value should be 0. That is here if you take minus as common, that is minus 2 plus 5m by 3 minus into minus plus m minus 0 obviously m, 0 minus 0 again 0, minus m minus into minus plus m. Here also we are unable to satisfy the net diversion condition. Why? Because we got a minus here. So obviously minus of maximum is this value only. So this arrow will represent x2. After that we have a minimum ratio rule. The minimum ratio rule is of you xb by xj. That is it will represent xb by, this arrow will represent x2. So we have xb by x2, that is 1 by 1 by 3, that is 3. 2 by 5 by 3, that is 6 by, take a pardon, that is 2 by 5 by 3, that is 6 by 5, that is 1 point something, and 2 by 5 by 3 obviously 1 point. Clear? So we have to consider plus of minimum here. So obviously we have to reduce this artificial variable without loss of generality and taking this 1 point value plus of minimum. So there is a time between these two. So our aim is to reduce all the artificial variable. In the first table we reduce that artificial variable a1. So this is the time to reduce the artificial variable. So there is some sort of a chance to reduce this artificial variable. Clear? If I am taking this 1 point something is the plus of minimum. If you combine these two, 5 by 3 is the key element. Because of this key element only we are unable to satisfy the net diversion condition. In the next, the last table of you, x2 is incoming. A2 is outgoing. A2 is outgoing means we are going to reduce this entire A2 column. So the problem is all about no question of m's here. Simply we can apply our simplex method. So bigger method is also one of the part of simplex method only. So after this, x2 is incoming vector, A2 is outgoing vector. The cost of x2 is minus 1. We have to make all the elements in the key column has to be 0. And the key element, we have to divide the key element with the unity to make the value as unity by dividing with 5 by 3. In order to divide with 5 by 3, it's better to multiply with 3 by 5. Hence, we have a third iteration table as follows. The third iteration table. So we have CB, YB, XB, and all the variables we have x1, x2, s1, s2 only. Why? Because we reduced all the artificial variables. That is, we have Cj, minus 2, minus 1, 0 and again 0. Here, x2 is incoming vector, a2 is outgoing vector. So obviously x2 will be here. The cost of x2 is minus 1, here we have minus 1 only. And then no changes for x1 and s2. So obviously x1 the cost will be minus 2 and s2 the cost will be 0. Now we have to make this key element as unity by dividing it. So in order to divide with 5 by 3, it's better to multiply with 3 by 5 for this entire row. Now I am going to multiply with this value with 3 by 5, that is again 3 to the 6 by 5 here. 0 and anything obviously 0. Into 3 by 5, 3 gets cancelled, 5 gets cancelled, obviously 1. Because of this only we are doing some sort of this multiplication here of you. Minus, I am going to multiply 3 by 5 and minus 3 by 5. Now this is 0 and anything again 0. Now we made this key element as unity by multiplying with 3 by 5. Now this is the time to make all the elements in the key column has to be 0. Now I am going to make this 1 by 3 as 0 by using some sort of row operations. I am using some sort of graph here, all of you. Now first you have to choose the variable that is 1 by 3. So simply you have to copy here 1, again 1 by 3. Again we have 0 and again 0. With the help of a key row, that is 6 by 5, 0, again So we have to get 0 here. Simply we have 1 by 3 here, we have 1. So I am going to multiply this entire row into 1 by 3. So that is 3 2 just 6. So that is 2 by 5. That is 1 minus 2 by 5. That is 5 minus 2. That is 3 by 5. This is 0. 1 minus 0 obviously 1. 1 by 3 minus 1 by 3 is 0. I am going to multiply with 1 by 3. That is 3 gets cancelled. Minus 1 by 5. 0 minus 2 minus 1 by 5 plus 1 by 5. Obviously 0 is 0. I am going to represent this entire row in the first row. That is 3 by 5. 1, 0, 1 by 5 and 0. So now we made this 1 by 3 as 0 by using some sort of row operation. Now this is the time to make this 5 by 3 as 0. So first of all we have to copy this entire row here. Now I am going to make this value as 0. So take this entire row 2, 0, 5 by 3, 0, 1 with the help of a key row, that is 6 by 5, 0, 1, minus 3 by 5, 0. We have to get 0 here. Without loss of generality, I am going to multiply with 5 by 3 with this. I am going to multiply with 5 by 3. So 5 gets cancelled, 3 2 just 6, so that is minus we are doing 2 minus 2 obviously 0. 0 minus 0 obviously 0. Here we are going to multiply with 5 by 3 obviously. 5 by 3 into 5 by 3 obviously 0. 5 by 3 minus 5 by 3 option 0. I am going to multiply with 5 by 3. 5 gets cancelled, 3 gets cancelled, minus 1, 0 minus 2 minus plus 1. 1 minus 0 obviously 1. Here we got zeros, 0, 0, again 0, 1 and followed by 1. So we make all the key elements has to be 0 here and key element as 1. Obviously we have a 3 massive formulas, that is maximum z equal to 3 2 is a minus 6 by 5, minus 6 by 5, obviously minus 12 by 5. And we have a zj formula. The formula of zj is CB into xj, minus 2, 0 and 0, obviously minus 2. And again 0, minus 1 and again 0, obviously minus 1, minus 2 by 5, minus into minus plus 3 by 5, obviously 1 by 5. And we have finally we have minus 2 into 0, 0, minus 1 into 0, 0 and 0 to 1 again 0. And we have a last step, that is the alternation condition, Zj minus Cj greater than 0. Minus 2, minus into minus plus 2, 0. Minus 1 minus minus plus 1, that is 0. 1 by 5 minus 0, that is 1 by 5. And 0 minus 0 obviously 0. So of you, in this case, the net diversion conditions are satisfied. Hence, we got a optimum solution for this. So we have the final conclusion for this. The maximum of z equal to finally we got minus 12 by 5. We got x1 equal to 3 by 5, x2 equal to 6 by 5. If you want to check it out, we can check. The checking is, so maximum just actually we made the given data in terms of maximum. So that is the checking. The given function is all of you. We made some sort of a changes by using a minimax theorem. That is minus 2x1 minus x2 will be there. So that I am going to submit all the values. Minus 2 into what is x1 we got? 3 by 5 minus what is x2 we got? 6 by 5. The x1 is 3 by 5, x2 is 6 by 5. That equal to minus 6 by 5, 3 to 6 minus 6 by 5. Obviously 5 is LCM, minus 6 minus 6, that is minus 12. Obviously we got minus 12 by 5 here, minus 12 by 5. Obviously we got minus 12 by 5. Hence the given LPP possesses optimum solution. Thanks for watching this video. Thank you.